Alright, you guys asked me to make a video. I'm going to make a video. It's going to be a very quick video because I really think that you guys should practice as much as possible to get you ready for this test. Alright, the first example that I gave you as a warm-up said solve the triangle. So the first thing you should always do for yourself, not so much for points, but for yourself, is draw the triangle. And label it so that you'll know where everything goes. So we have A is an angle, that's 56. Little a is 18, and B is equal to 21. That creates an ASS, which is a donkey problem. So the minute you have that donkey problem, make sure that you do a chart. So I'm going to have chart with triangle number 1 and a chart with triangle number 2. Always list the givens because the givens are the same no matter if you're in triangle number 1 or triangle number 2. So list your givens. And you know that with the donkey problems, you have to do law of sines. So that's what we're going to do now. We're going to do law of sines. So you set it up as 18 over sine of 56 equals 21 over the sine of B, since we're solving for B. Cross multiply and show that you're taking the arc sine, and we take the arc sine because we are solving for an angle. And once you put this into your calculator, you wind up getting 75.3. So 75.3 is your answer for B. Once you solve for B, you have to get its supplement. So, because you never know if your triangle at B is going to be an acute angle or if it'll be a bigger triangle where it might have an obtuse angle on that side. So that's why we find the supplement. So the supplement of 75.3 would be to do 180 minus 75.3, and you get 104.7. Now we need to find C. To find C, you're just going to add these two together. So that's 56 plus 75.3, and subtract those two from 180. And for that, you wind up getting 48.7. Do not take the supplement of this. Do not. To find C2, you're still going to add these two together. And subtract those from 180 as well. And for that, you wind up getting 19.3. So now the last thing that we have to do is find little c. To find little c, you're going to do the law of sines again. So for this one, you're going to set it up as C over the sine of C, which is the sine of 48.7, equals, use your given, 18 over the sine of 56. Cross multiply. And when you cross multiply and divide, you wind up getting 16.3. You're going to do the same thing again for C2. Okay, C2 is the bottom line. And you're going to set it up as C over the sine of 19.3 equals 18 over the sine of 56. Once again, cross multiply and divide. And for that one, you wind up getting 7.2. Okay, so it's very obvious that we have two solutions. We have two different values for B1 and B2, two different values for C1 and C2, and two different values for little c and little c2. Alright, so that is how we solve this problem, which we call the ambiguous case. Alright, the next problem was a little bit shorter. Remember, draw your triangle so that you can see what kind of problem you'll be doing. So we have big C is 85, little a is 14, and little b is 22. And we wind up having the law of cosines because this is an SAS problem. So whenever you have SAS, since we have been given big C, we can solve for little c. So we're going to write c squared equals a squared plus b squared minus 2ab times the cosine of c. Since we're solving for c, we'll put that in. A squared will be 14 squared plus 22 squared minus 2 times 14 times 22 times the cosine of 85. You can put this whole thing in your calculator. Okay, put the whole thing in your calculator exactly the way you see it. And when you do that, you wind up getting 626.3120625. This is when you take the square root, and now you'll round it to 25.0. So now we need to find the two other angles. So the next thing that we can do is do the law of sines. So after this, we're done with law of cosines. So we'll do the law of sines using what is given. So what was given was, only angle we could use was C. So we can do 25 over the sine of 85. And let's solve for A first, which is 14 over the sine of A. Show that you are cross multiplying and using the arc sign since we're solving for an angle. And you do 14 sine of 85 all over 25. And when you do that, you wind up getting 33.9. So now we have two angles, and to solve for the last angle, we're just going to add 33.9 plus 85 and subtract our answer from 180. And that gives us 61.1. Alright? So make sure that your angles always have degrees, because I will take points off for that. So that's an example of SAS. Okay, the next one says find the area. Being that we have all three sides, we're going to use Hero's formula. Hero's formula starts off with S equals 1/2 of A plus B plus C. This is called our semi-perimeter, and we need our semi-perimeter to be able to solve for the area using Hero's formula. So when you add 1/2 of 12 plus 14 plus 20, you get 23. So our area is K equals S times S minus A, S minus B, and S minus C. All of this is the square root. So I set this up as 23 times 23 minus 12, 23 minus 14, and 23 minus 20. I can put all of this in my calculator, just making sure that I have double parentheses in the front and the back. And I wound up getting, rounding it to the nearest 10, 82.6 square units. Please make sure that you write square units. Either square units or units squared. I just need to see some type of a unit. Alright, the next problem was a special problem for Parisa, so I called this my extra Parisa problem, and she wanted to know how would you do law of cosines when you have side, side, side. So I created a problem just for Parisa, so I hope that Parisa is watching this video. So I have A, B, and C, and I don't have any of my angles. So it is totally up to me which angle I want to solve for. So I think I'm going to solve for A, because A comes first in the alphabet. Easier to solve. So the formula would be A squared equals B squared plus C squared minus 2BC cosine of A. It does not matter how you set up the problem, just as long as your capital A matches what's after the equal sign. So I have 21 squared equals 24 squared plus 29 squared minus 2 times 24 times 29, all times the cosine of A. Since I don't have a value for A, I know I'm probably going to be doing the arc cosine at the end. So now I need to work things out separately. This has to be worked out separate. This has to be worked out separate, and this has to be worked out separate. Do not add everything together like we did on the second problem. So the first thing I'll do is 21 squared, which is 441. Then I'll do 24 squared plus 29 squared, which is 1,417. Then I'll do 2 times 24 times 29, which is 1,392, which is attached to the cosine of A. So I cannot attach these two together because this one has a cosine of A with it. So what I'm going to do is subtract the 1417 from 441. That gives me negative 976. Bring this down and divide both sides by negative 1,392. Now, being that I'm solving for the cosine of A, I'm going to use my arc cosine. Okay, so I put that into my calculator. And I wound up getting 45.5 degrees. That is my value for A. Now, I'm going to be done with law of cosines, and I'm going to move back to law of sines. So for law of sines, I'm going to do 21 over the sine of 45.5. And let's solve for B next. Equals 24 over the sine of B. I'm going to cross multiply and use my arc sine now instead of arc cosine. And the answer that I'm given here is 54.6. So that is my value for B. Now the final thing I need to do is just add 45.5 to 54.6 and subtract it from 180. And I wind up getting that angle C is 79.9. So that is how you solve law of cosines when you have no angles and you have to solve for all the angles. Alright? That's just for Parisa. Alright, the next one is the tree question. The tree question was a little weird for me, 4th period, I apologize. But the tree question was actually not that hard to set up. Whenever you have word problems, always try to underline things that will help you. So, you know he wants to measure the height of the tree. He walks exactly 100 feet from the tree. So I know that if he's walking in a horizontal direction, this will be my 100 feet here. So here is the guy who has walked 100 feet away from the tree. Now, he's 100 feet from the base of the tree and then he looks up. The angle from the ground, here's the ground, to the top of the tree, because he's looking up, this is an angle of elevation, which is what Gennaro was telling me 4th period. So since it's an angle of elevation, the 33 will go here. Now, this particular tree grows at an angle of 83 degrees. So basically, this is my tree right here. Okay, so here's my tree, and it's growing at an angle of 83 degrees. So that means that this tree, here's the angle of 83 degrees. So if you look at this triangle without looking at anything else, this triangle is an ASA triangle. Once we have ASA, that is the law of sines. So we're going to set up the law of sines because the question says, how tall is the tree? So we're trying to find that value. So now we can set this up, but we do need one piece of information because we don't have anything here that's across from 100, which we need. So we're going to add 83 and 33, and we get 116, and do 180 minus 116, and we get 64. 64 represents that angle up there. So now we can set up our law of sines. So we have 100 over the sine of 64 equals what angle is across from the tree? 33. So equals x over the sine of 33. So now we're just going to cross multiply. And then this will give us the height of the tree. And the height of the tree is 60.6 feet. Alright, so make sure you really read what the question is asking and really see what important parts of the problem can help me solve it and set it up. Alright, number 2 says an observer is by a river. So I'm just going to draw a river as if it's like a lake. Okay, so because we know that a river doesn't really have a start or end point. So imagine if we were drawing a bridge that goes across this river, and we want to measure the distance from one end of the bridge to the other. So from here to here. So an observer is near a river. Remember, I'm not really an artist. Everyone told me 4th and 5th period I need art lessons. I know. So he's observing. And And it says that he wants to calculate the distance across the river. He measures the angle between his observations of the 2 points on the shore. So here is one observation, which is the point away from him, and here is the other point that's closer to him. Put those two together, you get an angle. This angle here created is 28 degrees. The distance between him and the point on his side of the river, so we're talking about this distance right here, is 300 feet. The distance between, so that's the 300 feet, and then they said the angle formed by him, that's him, the point on his side, and the point across from the river. So that's 3 different points being used to make an angle. So when you use 3 points to make an angle, here's that angle right there. Okay, this angle here is 128 degrees. So as you can see, just from my picture, I wind up having ASA. So because I have ASA from my picture, I'm going to use the law of sines. They want to know the distance across the river. So we are missing some information. We're missing this top angle here, which will allow us to do the law of sines. So we're just going to add 128 plus 28, which is 156. Subtract that from 180, and we get 24. So now we can set up our law of sines. 300 over the sine of 24 equals x over the sine of 28. Cross multiply and divide. And you wind up getting 346.3 feet. So all I would be looking for on a word problem is how you set it up, what rule you're going to wind up using, and then solving. Okay, so 2 more word problems and then this video is done. Okay, so to approximate the length of a lake, so I'm going to draw a smaller thing than I did my river. So we want the length of the lake, so we want this whole piece right here. To approximate the length of the lake, a surveyor starts at one end of the lake and then walks 245 yards. So here's one end of the lake. I'm going to draw it down here because if I go up here, I'm going to wind up going into the word. So I'm going to draw it down here. So he decides to walk 245 yards. He then turns 110 degrees. So if you turn, this is your turn. And then he walks 270 yards. Oops. To the other end of the lake. So if this is where my turn is at 110 degrees, I need this inner, so this makes a supplementary angle. So that degree must be 70 degrees. So I wind up spelling out SAS, which is the law of cosines. So the law of cosines says that if I call this A, this will be angle A. And then these can be B and C. It doesn't matter really what order you put things in. So I'm going to use A squared equals B squared plus C squared minus 2BC cosine of A. I don't know what A is, so I'm going to plug in 245 squared plus 270 squared minus 2 times 245 and 270 times the cosine of 70. I can put all of this in my calculator. And I wound up getting 87,675.73504. Take the square root, and you wind up getting 296.1 feet. Not feet, but 296.1 yards. Remember, units are important, so if you forget units, you're going to get a -1. Alright, so last question for this video. Two airplanes leave an airport and the angle between their flight paths is 40 degrees. An hour later, one plane has traveled 300 miles while the other has traveled 200 miles. How far apart are the planes at this time? So you know they're leaving an airport. So here's the little control tower. One plane is going to go in one direction. The other plane is going to go in another direction. And the angle that's formed by both of these planes is 40 degrees. One plane decides to go at 300 miles. And the other plane decides to go at 200 miles away. And now we want to know how far apart are both of these planes. So once again, we have SAS, which means we're going to use law of cosines. Now I'm going to switch it up, and I'm going to call this B, which means I'm solving for B, which means this can be A and this can be C. And I switched it up because we always keep using the same one, and I'm telling you, you don't have to stay with that. So B squared equals A squared plus C squared minus 2AC times the cosine of B. And you'll notice that once we plug in the numbers, everything's the same anyway. So B squared equals 300 squared plus 200 squared minus 2 times 300 times 200 times the cosine of 40 degrees. So put this all in your calculator. And you get 38,074.66683. Take the square root, and you wind up getting 195.1 miles. So don't forget your unit. Alright, so it's very important to read the questions and see how they want you to set them up. Alright, so there goes your review for today. Good luck!